So what I was saying is that we just added a rule about getting all the x's on one side. This should be something you've seen before, but we'll go over it. Let me go ahead and move these up. Okay. So to get all our x's on one side, typically, not always, but typically I'll take the smaller one and subtract it from the larger one. So I'm going to subtract 2x from both sides. So then I get 13 plus 3x equals negative 8. And it's important to remember that negative is part of that 8. Okay? Now I'm going to just go back to isolating x. So I'm going to subtract 13 from both sides. So then I have 3x equals negative 21. Then I want just one x, so I'm going to divide by 3. So then I have x equals negative 7. And then often on your homework it will also say check each solution. So you'll plug your negative 7 back into the original equation. Don't do it into one of your transformed equations because you might have made a mistake somewhere up here. You've got to do it into the original equation. Okay, you try this one. Anybody else?
I got 2.
2, that's what I got. So we have 3 minus 4a equals 5a minus 15. So I've got to distribute to both. I'm going to add 4a to both sides because that will get rid of my negative. So then I have 3, if I add 4a, equals 9a minus 15. Then I'm going to add 15 to both sides and I get 18 equals 9a. So then if I divide both sides by 9, I get 2 equals a. So you just...
I can't believe I didn't distribute to the...
Oh, that's... See, but this is why we practice. Sometimes you have to eliminate a fraction before going forward with your steps. Now, you could use the distributive property here, but then you'd get these, you get 22 over 3 and 4 over 3. So sometimes, not always, but one of the options, and let me step back for a second. One of the things I really want you to learn from algebra, one of the most important things you'll learn from algebra, is being able to approach a problem and instead of just diving right in because you know some algorithm for how to solve, really think about what's the best approach here, okay? What will save me some time? What's the best approach? Because as you head on into college, you're going to have courses that are much more demanding, and if you have really good problem-solving skills and you approach a problem in the right way, you're going to save yourself a lot of time, especially if any of you is going into computer programming, that sort of thing. Because if you just take the brute force approach and use the method you've always learned, order of operations, for example, you're wasting time and you're going to end up being frustrated and not solving problems in a very elegant way, and sometimes not being able to solve problems at all. So a lot of what you're learning in algebra is stepping back and saying, okay, what's the best way to do this? So if I look at this, I'm thinking the best way to do this is not the distributive property. That might be the most obvious way, but an easier way here is to clear this out, get rid of that fraction altogether. So I'd like to multiply both sides of this equation by the reciprocal. Then I won't have any fractions, okay? On the other hand, if this was a 3 and that was a 9, using my distributive property would make sense because that would make my fractions go away also. Okay, so a lot of it's just looking at it and assessing, okay, what's the best approach here? So in this case, I'm going to multiply both sides by the reciprocal, so 3/2 times, and in that case, these actually work, okay? So 3/2 times 4m plus 6 equals 3/2 times 2/3 is just 1, so that's 2m plus 11. Now see, this works, the 3/2 times 4/6. Okay? If this had been like a 5 and something that didn't go evenly into 2, or that 2 didn't go evenly into, then I might have just multiplied everything by 3 and then used my distributive property, because that would have cleared out the fraction too, and we'll look at that. Okay, so 3/2 of 4, well 1/2 of 4 is 2, so 3/2 is 6, that's 6m. 3/2 of 6 is 9. Is everybody comfortable with that? Okay. Now I move on to my next step of getting all my variables on one side. So I'm going to subtract 2m from both sides, so that gives me 4m plus 9 equals 11. Then I want to isolate my variable terms, so I'm going to subtract 9 from both sides. 4m equals 2. And then I want just 1m, so I'm going to divide both sides by 4. So m equals 2 over 4. And I have to simplify that fraction. M equals 1/2. And again, in your homework, it'll often say go back and check, which means plugging this back in. Now, you guys try this one. And again, just like with this fraction, you can see when I multiply both sides by 4/3, I'm going to get, which is the reciprocal, well, that's going to work with this because these are multiples of 3. So it'll come out cleanly. If it wasn't going to, I could just multiply everything, both sides by 4, and get rid of my denominator. Okay, you have an answer? What'd you get? 6. Is that what you got?
I think I did mine wrong.
You did? Now, did you multiply by the reciprocal? Or did you multiply everything by 4?
Oh, okay, right, I knew that.
Now, you could distribute this, but it just makes it, I think, a little harder. Let's try multiplying by the reciprocal. So we get 4/3 times 3x minus 9 equals 6 plus x. So 4/3 of 3 is 4. 4x. And 4/3 of 9 is negative 12. Equals 6 plus x. And then if you subtract x from both sides, you get 3x minus 12 equals 6. Add 12 to both sides, 3x equals 18, and x equals 6. But I'm going to show you another method here that might be easier. Okay? I'm going to multiply, see, here's my denominator, it's 4. I'm going to multiply everything by 4. Okay? So if I multiply this by 4 and this by 4, then this becomes 12x minus 36 equals, well, I'm just getting rid of the 4 when I multiply that by 4. 3 times 6 plus x. So all I did was just multiply everything by that denominator. Now I have something with no fractions. So in some ways that's a little easier than this because you're still having to work with the fraction over here. And if that's hard for you, just multiply everything by the denominator. Okay, so then we have 12x minus 36 equals, this is 18, plus 3x. I'm going to subtract 3x from both sides. That gives me 9x minus 36 equals 18. I'm going to add 36 to both sides. 9x equals 54. So then x equals 6. Do you like that better?
Yeah, yeah.
Then you don't have to deal with this.
So
Okay, and that will always work. It would have worked here too. You could have just multiplied everything by 3.
So do you multiply the 4 on the other side too? Like you multiply 4 on the left side, do you?
Left side, but this side, when I multiply by 4, it's just getting rid of this. It's just canceling the 4 in the denominator. But you have to multiply this by 4. Because whatever I do to one side, I have to
Yeah,
do
that
to
makes
the
a lot
other.
of sense.
You like it?
Yeah.
And this makes my numbers a lot easier,
Yeah.
right? Okay. And you can always do that with fractions. If you're not comfortable multiplying by the reciprocal, you multiply by this. It means you still need to do the distributive property here, but that's okay. Cleaner numbers. Yeah. How many solutions? Equations don't always have just one solution. If you get down to the end and you're solving it and you get something like 3 equals 3, okay? Something that's always true, then that's called an identity. Okay, and an identity has all real numbers as a solution. Because if I get, well, let's see, is this one? That's not one. Well, we'll get one, and I want to talk about why that's true. Okay, another way to remember this is if it's always true, then it's all real numbers. They both begin with A. Okay, if you get something that's always true, like 3 equals 3, then the solution is all real numbers. Some equations have no solution. When that happens when the equation is never true, like you get 3 equals 2. Go through all your work and you get 0 equals 6. Wait, something's wrong. Oh, then that equation has no solution. So if it's never true, it has no solution. So the ends match on that one. If it's always true, it's all real numbers. Never true, no solution. This isn't your solution though. This is what you have to put. That's your solution. All real numbers. If it's always true, it doesn't matter what x is, what your variable is. This 3 equals 3 is going to be true no matter what x you put. That's why it's all real numbers. 3 equals 0 will never be true no matter what x you put. So that's why it's no solution. So let's try a couple of these. First, we're going to do the distributive property. So we get 9z plus 12 equals 9z plus 27. Well, I can subtract 9z from both sides. I mean, you can already see that this is never going to be true, right? But I can subtract my 9z from both sides and get 12 equals 27. Well, that's never true. It does not matter what z I put in there. I can't make that statement true. So it's no solution. So your solution is no solution. That's the answer to the problem. Often a clue that some of these are going to be in there is your instructions will say solve if possible. So then you know you might get some no solutions. Okay, this one's a little tricky. I'm going to subtract 1 from both sides, and I'm going to get 7w equals 8w. Now I'm going to subtract 7w from both sides. That gives me 0 on this side and w on this side. Be careful because that is a solution. W is 0. This is not a no solution. Some of my students at Iron Horse want to say, oh, no solution. No, 0 is a solution, so that's okay. If w equals something, that's a solution. Okay, so you do the U try. What'd you get?
6 equals 6.
So that's always true, so it's all real numbers. Because it's 6a plus 6 equals 6a plus 6. Well, even if I subtract, you can see already that this is an identity, because it's got to be true. But you could subtract 6a from both sides and get 6 equals 6, if that helps. And that's always true, so it's all real numbers. Good. Or you might have subtracted 6 from both sides. You might even end up, if you subtract everything, you get 0 equals 0. But even at this stage, you can tell that it's all real. And you can just do that if you want.